Another night arrives, bringing with it a clear sky adorned with stars. However, despite the familiarity, this night does not belong to our planet Earth, but rather to the nearby planet Proxima B, belonging to the star closest to us. It is possible to see our sun from there, but even though it is a close neighbor observed from here, it is very faint and difficult to locate. From the skies of this planet, the sun is about 25 times less bright than the brightest star in our skies, Sirius, being just another dim star without standing out among the others. This is not to mention that the stellar system where the planet is housed is also illuminated by a very close system, formed by two stars very similar to the Sun, the Alpha Centauri system, which further dims the brightness of our star. The fact is that observing our home from other planets is perhaps one of humanity's greatest dreams. Indeed, not only a dream, but also a milestone that has been pursued with various programs, including NASA's Artemis program. As Bill Nelson, NASA administrator, says,
"Humanity is preparing to conquer the planets of the solar system and then conquer the stars."
However, the challenges to achieve this goal are enormous, but the technology that will allow us to get there is already being tested. Let's understand how they intend to do this. Although Proxima B is a planet in another star closer to us, we know very little about it compared to other stars much further away. This is because Proxima B does not transit in front of its star when observed from Earth. Its orbit, inclined relative to the plane of the Milky Way, is not aligned with our line of sight. Because of this, it never passes between its star and Earth, and consequently, we cannot see its transit. Without the transit, it becomes much more difficult to observe the details of the planet's atmosphere. To make matters worse, the James Webb Space Telescope, the most powerful equipment we currently have in space, cannot directly observe Proxima B because it is too close to other light sources that interfere with its detection. So, to observe it, other methods that capture visible or radio light, which are less affected by interference, must be used. These methods provide us with more limited information, which consequently leads us to have a more limited understanding as well. To know in detail everything that exists there, we would have to send a spacecraft. But that would be very difficult and time-consuming with current technology. Currently, one of the energy sources we use for space missions involves solar energy, a renewable and clean energy source that can be used to power satellites, probes, and spacecraft. However, it also has some limitations when used to explore more distant places in the solar system. One of these limitations is the distance from the Sun. The farther away, the lower the intensity of the sunlight reaching the solar panels. For example, on Mars, solar light is about 40% of what we receive on Earth. On Jupiter, it's only 4%, and when we reach Saturn, the amount of sunlight is less than 1%. This means that to generate the same amount of energy, much larger and heavier solar panels and batteries are needed, increasing the cost and difficulty of launch and operation. Batteries also have limitations in capacity, weight, lifespan, and resistance to low temperatures. To explore the solar system beyond Saturn, where sunlight is much weaker, we use a technology called radioisotope thermoelectric generator, which stands for RTG. This technology uses the heat generated by the radioactivity of a material to produce electricity, so we don't depend on the distance from the Sun or the duration of the day. Currently, it is used in the Voyager and New Horizons probes, which have reached the outer reaches of the solar system. However, this technology also has limitations because, in addition to using radioactive materials that are dangerous and scarce, they produce a limited amount of energy for a limited time. Therefore, it is not sufficient to accelerate spacecraft to high speeds, which is necessary for traveling to other stars. This problem is so complex that the New Horizons probe, the fastest spacecraft ever created by humans, reaching 80 km/h using RTG technology would take only 74,000 years to reach Proxima B, which clearly makes the mission unfeasible. However, NASA is changing this scenario with a nuclear-powered spacecraft known as Draco. It is expected to make its first demonstration in space by 2026, using technology that reduces the time from 74,000 years to just 85, which is still a long time but much more acceptable than 74,000 years.
NASA will partner with our longtime partner, DARPA, to develop and demonstrate advanced nuclear thermal propulsion, a revolutionary technology that will allow the United States to expand the possibilities for future human spaceflight missions. Our goal is to launch and demonstrate a successful nuclear thermal engine as soon as 2027. The idea of nuclear thermal propulsion is not new to NASA or to many. A half-century ago, the United States conducted its last nuclear thermal engine test under NASA's Nuclear Engine for Rocket Vehicle Application and rover projects. Here's what we learned and we know to be true. Conventional chemical propulsion is not the most efficient way for our astronauts to do a deep space mission. Nuclear thermal propulsion is much more powerful, with 2 to 5 times the efficiency of chemical propulsion. And with the help of this propulsion system, astronauts will be able to journey to and from deep space faster than ever, a major capability to prepare for crewed missions to Mars. Deputy Administrator Pam Melroy has led NASA's strategy for sustained human presence in deep space. Our Moon to Mars objectives are guiding our work, and we are now beginning to outline the architecture for future exploration, not only with nuclear thermal, but also possibly with nuclear electric propulsion. Expanding our partnership with DARPA and its Draco program will help, and it will help us create a new era of space transportation.
In it, nuclear energy is released through the breaking or joining of atoms, which produces much more heat and energy than radioactivity. With this, it can be used to generate electricity or propulsion for spacecraft, potentially accelerating the spacecraft up to 5% of the speed of light, which would allow travel to stars near the Sun in much less time. Nuclear energy, besides being independent of the Sun, brings many advantages. It is more compact and lightweight and quite powerful and efficient. But it also carries risks in cases of accidents during launch or for the crew if there is a leak if inhabited during the journey, which will certainly require strict control in its use. There are also other problems involving this type of travel, such as stopping the spacecraft over time, and how to prevent the impact of small objects from causing damage. Since at high speeds, no matter how small the debris, it can still cause great damage. But these problems, I am sure, are much easier to solve than the travel time. So it's a real chance for humanity to finally have access to planets orbiting other stars. That's it, folks. I hope you enjoyed it. Share with us what you think about it, including if you have any doubts. And if you're not already part of our community, leave a like and subscribe, as this is essential for the channel to gain prominence, which consequently helps us create more content like this. Thank you so much, and see you next week.